Okay, hello everyone. In this lecture series, we are discussing questions based upon variational principle. In the last class, we discussed this question and this question in detail. This question, both are asked in CSR net. In today's class, we are going to discuss another important question. Question number 7. Evaluate ground state energy of a linear harmonic oscillator of mass m and angular frequency omega using the trial wave function psi x given as n cos pi x by 2a in between minus a to a. Mod x less than a means minus a to a, otherwise it is 0. Okay, so let us start. As we know, to solve a question based upon variational principle, we have to follow these steps or procedure. First, we have to write the Hamiltonian of the system, then we have to consider the trial wave function, and if it is not normalized, then we have to normalize the trial wave function, then expectation value of Hamiltonian, then minimization condition. Here in the question, trial wave function has been given n cos pi x by 2a. Here n is your normalization constant. Okay, so first we have to normalize the given trial wave function. Before that, we have to write the Hamiltonian of the system. Okay, according to the steps, first step is that Hamiltonian of the system. Hamiltonian of the given system is H equal to Px square by 2m, because it is one dimensional harmonic oscillator. Here you can see x is there in your wave function, only x is there, so it is a one dimensional harmonic oscillator. Px square plus Vx, this is the kinetic energy part, this is the potential energy part, which will be equal to, if I am going to consider Px operator value, that is your minus I h cross del by del x, then this Hamiltonian operator will be written in this form as minus h cot square by 2m del square by del x square or d square by dx square, because only x-axis differentiation is present. Potential will be half m omega square x square. M is the mass given in the question, omega is the angular frequency. Okay, now we are going to go for normalization of trial wave function, because in the question itself we can found that the trial wave function is not normalized. So as per our second step, we have to normalize the trial wave function. Normalize the trial wave function. So directly I am going to write the normalization condition. As per the condition, as per the normalization condition, what we know, the inner product of psi should be 1. That means minus infinity to plus infinity, as it is one dimensional, so psi star psi dx should be 1. That implies here we have to consider the limit, because the psi exists in between minus a to a, so we have to write that minus a to a psi star. Here psi value in between minus a to a is your n cos pi x by 2a, so psi star will be n star cos pi x by 2a into psi, that means n cos pi x by 2a should be equal to 1. That implies n star n is nothing but n mod square taken outside of this integration. Minus a to a is the limit, cos square pi x by 2a dx. Here I forgot to write dx. dx should be 1. Here dx should be equal to 1. That implies n mod square, this is the common integration that you can do by yourself easily. Here I am writing here cos square theta, cos square pi x by 2a can be written as 1 plus cos 2 theta. Cos 2 theta means 2 pi x by 2a, so 2 got cancel. I can write pi x by a by 2 dx is equal to 1. That implies n mod square, here 2 also can be taken outside of this integration, minus a to a 1 into dx, one integration, then plus minus a to a another integration, that is your cos pi x by a dx equal to 1, right? That implies n mod square by 2, this integration is your x, limit will be minus a to a, here plus, okay, plus this cos pi x by a integration will be sin pi x by a by pi by a, limit will be minus a to plus a equal to 1. That implies n mod square, here I am in detail writing the steps. You write down in your note, but in your exam you can omit the steps. So here x minus a to a is the limit, so if we are going to put the limits upper and lower, we can find the value will be 2a plus here upper limit, if I will put over here, I can get sin pi, value is 0. If I will put minus a, also minus sin pi, the value also is 0. So this term value will be 0 always, is equal to 1. So that implies normalization constant value, how much we can get? We can get here 2 got cancel, it will be 1 by a root over, that means root over of 1 by a. We found normalization constant is this one. Therefore normalized wave function will be 1 by a root over into cos pi x by 2a. Okay, so here we found normalized wave function as this one. This wave function will be used to find out the expectation value of Hamiltonian. Our third step is your finding the expectation value of Hamiltonian. You just write a heading, expectation value of Hamiltonian, h cap, okay, which is nothing but this one. That implies expectation value of h cap, here psi is the normalized wave function we are going to consider. So this is nothing but your minus infinite to plus infinite psi star h cap psi dx divided by psi star psi dx minus infinity to plus infinity. So as we considered here, psi is your normalized wave function. So if you are going to do this calculation, this will be 1. So this denominator part no need to write. Expectation value of Hamiltonian is this much, minus infinity to plus infinity psi star h cap psi dx. No need to write the denominator part because we are considering the normalized wave function, right? Or this integration limit as per the question will be written as minus a to a psi star h cap psi dx. Here h cap value we have to put this much, minus h cot square by 2m d square del square by del x square plus half m omega square x square, and we are going to calculate the expectation value of Hamiltonian. Okay, so that implies expectation value of Hamiltonian is equal to, you just write first, minus a to a psi star value is what, 1 by a cos pi x by 2a. Okay, then Hamiltonian value is your minus h cot square by 2m minus h cot square by 2m del square by del x square plus half m omega square x square. Then again we have to write the wave function psi 1 by a root over cos pi x by 2a dx. That implies expectation value of Hamiltonian will be equal to, here 1 by a root over 1 by a root over, that is your 1 by a taken outside of this integration, minus a to a cos that implies expectation value of Hamiltonian will be equal to, here 1 by a root over, here 1 by a root over taken outside of this integration, 1 by a minus a to a cos pi x by 2a minus h cot square by 2m del square by del x square plus half m omega square x square cos pi x by 2a dx. Now here we can write by two terms. This is your kinetic energy part, this is your potential energy part. You just segregate by two integrations, 1 by a minus infinity to, sorry, minus a to plus a cos pi x by so that implies expectation value of Hamiltonian will be equal to 1 by a root over 1 by a root over. So it will be 1 by a whole into minus a to plus a cos pi x by 2a whole into minus h cot square by 2m del square by del x square plus half m omega square x square into cos pi x by 2a into dx. Okay, that implies expectation value of Hamiltonian will be 1 by a. See, here I am going to segregate by two integrations by considering this one term, this one another term. This is your kinetic energy part, this is your potential energy part. So 1 by a minus a to a cos pi x by 2a minus h cot square by 2a is there, then del square by del x square operated over cos pi x by 2a dx. This will be one integral, another integral will be here plus 1 by a is there. Here you can see half m omega square is the constant, you can take outside of this integration, half m omega square taken outside of this integration, minus a to a, here cos pi x by 2a, cos pi x by 2a it will be cos square pi x by 2a and x square is there. So it will be x square into cos square pi x by 2a dx. Okay, that implies expectation value of Hamiltonian will be 1 by a minus a to a. Here you can omit the step. Here this step you can omit in your exam. Okay, it will be cos pi x by 2a into minus h cot square by 2m already is there. Here if I am going to differentiate this cos pi x by 2a two times with respect to a, then I can found first time derivative if I am going to do, then I can get pi by 2a minus sin x sin pi x by 2a, then again pi by 2a, that means pi by 2a square minus cos pi x by 2a. So this will be how much? Pi by 2a square into minus cos pi x by 2a into dx. Okay, and second integral will be here m omega square by 2a, m omega square by 2a. Here x square is the even, cos square also even. So this is a even function, can be written as 2 into 0 to a x square into cos square pi x by 2a into dx. That implies expectation value of Hamiltonian will be equal to, here you can see this minus, it will be plus h cot square pi square, this will be 4a square, here 2 8m and another a taken outside of this integration. So what we can found? We can found as here h cot square pi square whole divided by, this will be 4a square, this will be 2m, that means 8 and here a is there, 8m aq minus a to a cos square pi x by 2a into dx plus m omega square by a, because 2 got cancel, this 2 got cancel, 0 to a x square into cos square theta can be written as what? 1 plus cos 2 theta by 2, that means cos 2 pi x by 2a will be your pi x by a whole divided by 2 into dx. Okay, so that implies expectation value of Hamiltonian will be equal to h cot square pi square by 8m aq. This integral value will be a. How? Already we have been discussed at the time of normalization. Here minus a to a cos square pi x by 2a dx is your how much? 2a by a is your a only. So this integral value will be a, directly I am writing over here. Okay, no need to calculate, 1 second. Plus m omega square a, here we can get the two integrations, 0 to a x square dx, here 2 can be taken outside of this integration, m omega square by 2a. Okay, 0 to a x square dx. Okay, plus x square into cos pi x by a dx. That implies expectation value of h will be equal to h got square pi square. Here a got cancelled, 8m a square. Okay, then m omega square by 2a is there written as such. Here integration of x square will be x cube by 3 and the limit will be 0 to a. Okay, plus integration of x square cos pi x by a dx. This type of integration can be done easily by using क्रॉनेसर method. क्रॉनेसर method means suppose we have like this gx fx integration, then it can be written like this: gx integration of fx, then minus g dash x double integration of fx, then plus g double dash x triple integration of fx, and so on until this term will be 0. Okay, so we have to use this क्रॉनेसर method. Here gx is your x square, fx is your cos pi x by a. So the first term will be x square, second term will be integration of fx. Integration of fx means will be minus, sorry, cos means plus sine pi x by a by pi by a. Okay, then minus g dash x means 2x, then double integration of cos pi x by a. Already first integration value we have. If we are going to do another integration, then it will be minus cos pi x by a divided by pi by a whole square. Then third term will be plus double derivative of gx. Double derivative of gx will be 2 only. Okay, here single derivative is 2x, double derivative will be 2, and triple integration of fx. Double integration value is this one. Triple integration if I am going to consider, then it will be minus sine pi x by a by pi by a whole cube. Okay, then g triple dash x value will be 0 and other terms will be 0. No need to write. This integration also you can do by considering islet. So here limit will be 0 to a. We have to substitute 0 to a. Okay. Okay. So that implies expectation value of Hamiltonian will be h got square pi square by 8m a square plus m omega square by 2a. This value will be a cube by 3 plus here you just put a value over here and here. First upper limit we can get sine pi is your 0, lower limit sine 0 also 0. That means this term will be cancelled out by substituting upper limit and lower limit. Likewise this term also will be cancelled out. Now consider this one will be here minus plus is there. Okay, so first limit if I am going to put, it will be 2a cos pi by pi by a whole square minus if I'll put 0 over here, then this term will be 0. Okay, so here we found expectation value of Hamiltonian will be equal to h got square pi square by 8m a square plus m omega square by 2a. Here you can omit the steps in your exam. Okay, a cube by 3 Here cos pi value is your minus 1, so it will be minus this a square will be moved to numerator, then it will be 2aq by pi square, 2aq by pi square. So finally we found the expectation value of Hamiltonian is your h cot square pi square by 8m a square plus here a 1 by a multiplied with this term and this term, it will be half m omega square is there, so 1 by a if it will multiply it, then we can get a square by 3 minus 2a square by pi square. So finally we found this is your expectation value of Hamiltonian by considering the normalized wave function, where a is the parameter. So for minimization of expectation value of Hamiltonian, we have to consider the derivative of this Hamiltonian with respect to a. This is your expectation value of Hamiltonian Okay, now we are going to consider, clearly you write, it will better. This is your final expression of expectation value of Hamiltonian. Expectation value of Hamiltonian. Okay, now we are going to go for the minimization of Hamiltonian. Our fourth step, minimization by considering parameter a. Minimization of expectation value of Hamiltonian by considering the parameter a. That means we have to differentiate the expectation value of Hamiltonian with respect to a and equate to 0. So what is the meaning of this heading? The meaning of this heading is nothing but d by dA of expectation value of Hamiltonian, whatever we found, will be equal to 0. This is the minimization condition. Here a is the parameter. Okay, so that implies, see here, differentiation with respect to a. First term is this one. So here constant is your h cot square pi square by 8m. We have to write h cot square pi square by 8m, and we have 1 by a square. 1 by a square with derivative with respect to a is nothing but minus 1 by a to the power 4. Derivative of a square is your 2a. So finally we can get minus 2 by a cube. Directly I have to write, okay, or you can write, no problem, minus 1 by a to the power 4 into 2a, right, plus half m omega square is there, then a square by 3. So differentiation with respect to a means it will be 2a by 3. Then 2a square by pi square, it will be minus 2a means a square means 2a, so it will be 4a by pi square will be equal to 0, right? That implies minus h cot square by 4m. Here you can see 2, 8 got cancelled, you can get 4m minus h cot square by 4m, because this is minus. Here pi square by a cube, because 1a got cancelled with a to the power 4, plus half m omega square. As such, you just write 2a by 3 minus 4a by pi square will be equal to 0. Here you can omit all the steps write the final answer, but here I'm writing all the steps. You just write in your note h cot square by 4m pi square by aq. This term, if it will move to this side, it will be minus, so this minus will be got cancelled. It will be equal to half m omega square 2a by 3 minus 4a by pi square. Clearly write this is the 3. Okay, 3. So that implies, here you can see this 2 got cancelled. We can found 2m, and m omega square will be moved this side. So here left hand side will be h cot square pi square by 2m square omega square. Okay, and this aq moved this side, multiplied with this a. Here a we can take common from these two terms, so it will be a to the power 4 whole into 2 by 3 minus 4 by pi square. Right, right. That implies a to the power 4 will be equal to h cot square pi square by 2m square omega square into 1 by 2 by 3 minus 4 by pi square. Okay, so it can be written as, here you can see 2 can be taken common from these two terms, so it will be h cot square pi square by 4 m square omega square into 1 by 3 minus 2 by pi square. So here this value will be a to the power 4 will be h cot square pi square by 4 m square omega square into, here if you are going to subtract these two terms, we can found what, 3 pi square minus 6, right? So if I'm going to uh, take this term to the numerator, so the reverse will be 3 pi square by pi square minus 6, pi square minus 6. Okay, now a will be a value. That implies, here we found a value equal to the power 1 by 4. This much term to the power 1 by 4. That means here you can see pi square pi to the power 4. That means we can get pi h cot square by 4 m omega to the power 1 by 4. That means it will be h cot by 2 m omega root over, okay, into, here pi square already taken, so it will be 3 by pi square minus 6 to the power 1 by 4. So this is your a value. What we have to substitute in our expectation value of Hamiltonian. Here we found the a parameter. Now substitute this a value in this equation. You can put this equation as your equation number 1 itself. Put a value in equation number 1, we found. Now put a value a in equation number 1. We get whatever we can get, that will be your ground state energy value. Okay, because equation number 1 represents the Hamiltonian of ground state energy. Okay, expectation value of ground state, this equation number 1 represents. So if we are going to put the a value, then it will be give you the expectation value or eigen value of ground state of the ground state of this system. Okay, so carefully we have to substitute. Here A is there, here A is there, here A is there. So carefully we have to substitute. That implies expectation value of Hamiltonian, or you can write ground state eigenvalue EGS will be equal to h cot square pi square by 8m. already is there. H cot square pi square by 8m. Just write h cot square pi square by 8m into 1 by a square is there. 1 by a square. Here you can see it is 1 by a square. So instead of a, what we have to put? This value. So if I will put this value, then a square means this pi will be pi square, and this root over will be removed. It will be h cot by 2m omega. Okay, then here this term 3 by pi square minus 6 to the power 1 by 4 is there. So its square will be how much? Root over of this one. Only we can find root over of this one. 3 by root over of 3 by pi square minus 6. Okay. First term काम खत्म. Second term, in the second term here half m omega square is there. First you just write plus half m omega square then in bracket a square by 3, bracket starts a square means this value itself. We have to write this value by 3. That means it will be pi square by 3. This is 3. Okay, into h cot by 2m omega into root over of 3 by pi square minus 6. Okay, then another term is there, minus 2a square by pi square, 2a square by pi square, minus 2 by pi square. First you just write, then you write a square value. 2a square by pi square, not 2 by pi square written, then a square value is this much. You just write pi square h cot, put this bracket, curly bracket, it will better. Put the curly bracket, pi square h cot by 2m omega, then root over of 3 by pi square minus 6. Close the bracket. Okay, now we have to carefully solve this one. In your exam you can omit these steps, but here I am solving each and every step. Carefully you have to watch. Will be equal to, here you just write first h cot square pi square by 8m. Okay, 8m pi square is there. Okay, 8m pi square, you just write this one. Then this one, if it will be right, then it will be reverse, means it will be 2m omega by h cot. That means it will be 2m omega by h cot, and if this denominator part will be moved to the numerator, this will be pi square minus 6 by 3 root over. Okay, then plus half m omega square is there. Just write, do not change anything. Then this will be h cot pi square by 6m omega 3 by pi square minus 6 whole root over. minus minus, here you can see pi square got cancel, 2 got cancel, and we can found h cot by m omega whole root over of 3 by pi square minus 6. You just omit these steps in your exam, but I suggest you just write in your note, it will better for your practice. That implies EGS, ground state eigenvalue, will be equal to here pi square got cancel, here h cot 1 h cot will be got cancel, m will be got cancel, 2 will be cancelled with 8, it will be 4. So we found h cot omega by 4, h cot omega by 4, okay, h cot omega by 4 pi square minus 6 by 3 root over plus here half m omega square multiplied with this term and this term. How much we can get? We can get 1 by 12 h cot omega, because here m got cancelled, 1 omega will be cancelled out, h cot omega pi square, then 3 by pi square minus 6 whole root over, then this value will be multiplied with this one, means minus, and here m will be cancelled out with m and omega, and we found h cot omega, right, h cot omega by 2, 3 by pi square minus 6 whole root over, okay. That implies EGS will be equal to, this step watch carefully here, h cot omega by 4 is there, you just write as such, pi square minus 6 by 3 plus here, if we are going to consider these two terms, h cot omega 3 by pi square minus 6 root over, and also here 2, here 12 are the common factors, can be taken outside. That means here we can take common from these two terms, h cot omega by 2 into 3 by pi square minus 6 whole root over, then we can found what, 1 by 6 minus, sorry, pi square by 6 minus 1, pi square by 6 minus 1, this much we can found, right. That implies EGS will be equal to h cot omega by 4 pi square by minus 6 by 3 whole root over plus h cot omega by 2 3 by pi square minus 6 root over into, this value will be how much, this value will be pi square minus 6 by 6, okay. That implies EGS, you just omit these steps in your exam, repeatedly I am telling to you, no need to write these steps, these calculations in your exam. Here 6 is there, if I'll take 2, then it will be 2 into 2 4, and this will be 3 by pi square minus 6 root over, and this will be written as pi square minus 6 by 3, right, h cot square by 2, and this is 2 taken outside from this bracket, so it will be 4, okay. That implies EGS, here you can see Here this root 3 got cancelled. Root over pi square minus 6, here pi square minus 6 got cancelled, and we found EGS is equal to h cot omega by 4 pi square minus 6 by 3 whole root over plus h cot omega by 4, and this will be pi square minus 6 by 3 whole root over, right? So finally, how much we can get? 1 by 4 h cot omega, this term 1 by 4. Finally, we found ground state energy value is equal to half h cot omega pi square minus 6 by 3 whole root over. So this is your final answer. This represents the ground state energy of given linear harmonic oscillator. Okay, so here I suggest that you just remove these calculation steps, no need to write. Here I written for your practice, you just remove the calculation part in your exam. Okay, if this is the normalization condition, so this is a simple normalization derivation, n equal to 1 by a, and here whenever you are going to calculate the expectation value of Hamiltonian, few steps you can omit. Likewise, minimization condition, for minimization condition you can omit many steps, and by after substitution a value in your expectation value of Hamiltonian, directly you just remember, if you remember this value, it will be better, because particularly this question asked many times in your exam for 3 to 5 marks. So 3 to 5 marks means you have to complete your work within 2 pages. So practice this question, then how you can complete in 2 pages, it will better. Okay, so here I am going to stop our today's discussion. In our next class we are going to discuss finding the fast excited state eigenvalue or energy value eigenvalue by using variational method. One question we are going to solve on this topic: how to find the fast excited state eigenvalue by using variational method. So thank you so much for watching this video. Thank you.